All right, we are recording. Okay, so this is a video for going over Q2W4A, and it's focusing in. Okay, here we go. So, number one, 7-1A, 1 over 10,000. Which of these is going to work? Let me turn that sound off here. All right, so here we go. So we've got 1 over 10 million. I see 1, 2, 3, 4, 5, 6, 7 zeros. Now, a lot of kids will go, oh, there's 7 zeros. But remember, this is a small number. You're going to want to use 10 to the negative 7. The next one over here is decimal form. You're going to get rid of the large number. A fraction can't all of a sudden be equal to a large number. I'm going to count out the zeros here. 1, 2, 3, 4, 5, 6, 7. That's too many zeros. We want 1, 2, 3, 4, 5, 6, 7, a total of 7 zeros. So it's going to be that. Okay. The next one we are doing is standard notation. So we're working this out basically. I'm going to write down my 5, 2. This means the decimal is going to slide right 6 places. So one of those places is taken by the 2. So I'm only going to need 5 zeros. So then I'm going to put that in. If you think I made a mistake, shoot me an email or let me know, but I'm going through this rather quickly. So when it's a negative exponent, it's going to have that many zeros total. The exponent tells you. So 1, 2, 3, 4, 5, 6, 7, and then I'm putting my 3, 2, 9. I've got videos explaining this. You can check those out. So this one, 4/7. So I'm going to go ahead and go 0.34. This is going to be 0.068. 3/8. If you don't know that by heart, it is going to be let's see, 8 goes into 30. It's going to be 375. This one, 7 goes into 45 times. And then you do that annoying song. I'm sorry, yeah. You sing that annoying song, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4. And you can just, basically, you've got enough information. You don't even need to work it out any further. You've got the 6 cents. That's your smallest. 34 cents. 37 cents. 57 cents. Now, some kids might be able to eyeball it and just go, hey, that's more than a half, so it's going to be here. This is real close to nothing, so it's going to be the smallest. So it's good if you can do that. All right, the next one. Okay, square root of 144 is 12. If these two were switched, if it was like this, then it would be true, but it's not. This is 7, this is 9. Square root of 256 is going to be 16. 7 plus 9 does work out to 16. If the radical sign was around the 25, this would work. This one is true. This is 5, but square root of 10 and square root of 20, they're not even rational numbers, so it's not going to work out to 5. Okay, so we have in the morning, here's 0 degrees, it was -4. Then the afternoon temperature rose to 12. They're saying the difference, so one way to think about it is how far apart they are. You could say, hey, 12 and 4, just add them together. The other way you can do it is you can think of this as larger. Difference always means larger minus smaller. 12 minus -4, which becomes plus, and 12 plus 4 is 16. Absolute value of -5. Well, you find out -5 on the number line is right here. And -5 is 5 away. So you'll want choice B. You'd never have a negative distance. This one. Okay. We've got flat rate of $12.99. So that means no matter what, he's paying $12.99. $3.75 per hour. $3.75 per hour. We don't know what the hours are, but then they tell us that it's 4.5 hours. I'm going to go ahead and put it in as 4.5. All right. Now this is where you can get a calculator. You could even type this entire thing in your Desmos calculator and it'll work. I'm going to go grab a calculator. So if you're working this out step by step, you're going to go $3.75 times 4.5, and you get $16.88. It would round to $16.88 plus $12.99. So I'm going to go $16.88 plus $12.99. And you get $29.87. So that's the total bill. On this next one, they're asking about sale price, and they give you the discount rate. So this is going to involve two operations. First operation is going to be 35% of 85. So I'm going to type that in. I'm going to go 0.35 times 85. And I get $29.75. That is the savings, but it's not the sale price. Now we do 85 minus 29.75. I'm going to do a trick here. I'm going to make this number negative, and then I'm just going to add it to the 85. That's 55.25. So 85 minus 29.75 gives you that. All right, moving on. Similar figures. Triangle LMN is similar to triangle something. Now, a lot of kids just want to go alphabetic, E, F, G, but you don't want to do that. You want to look at corner L. You want to do corner L, and it's going to go with corner F, or vertex F. So L goes with F. M was the single arc. G is the single arc. So I'm putting the G here. N was the double arc. And E is the double arc. Now, doing these corresponding sides, you could use the picture. FG goes with LM. It might be easier for you to use the description, though. Look at this. FG is the first two. LM is the first two. EF, last back to front, NL. And you put your little line segment bar. NM is last to middle. EG is last to middle. All right, moving on. Now they say to use 3.14 for this. So this is going to be, instead of pi, I'm putting 3.14. N, I'm using 8. Pi is 3.14. N is 8 again, and M is 4. So I'm going to be typing this in and this in. If you have a Desmos calculator, you could type this entire thing in, and it'll give you the answer. Before I type this in, I'm closing my room door. Hang on. Hey, how are you? I'm doing all right. All right. So I'm immediately looking at this 8 to the second, and I see that that's 2 times 3.14, times 64. Then I'm going to work this part out momentarily. So this is where you'll start to see the benefit of using a Desmos calculator. It makes life real easy. So I'm going to go ahead and go, I'm going to go 2 times 3.14 times 64, and I get 401.92. And then over here, I'm taking care of this. That's going to be 2 times 3.14 times 8 times 4. And I'm going to get 200.96. Now I'm going to add these two together. Okay, punching the wrong buttons. 200.96 plus 401.92. I get 602.88. And that's that. So we're looking at the other side. So draw a line with a y-intercept of 3. Y-intercept of 3 means it's hitting the y-axis at 3. passing through the point 2, 1. Hey, there's 2, there's 1. So this line is going like this. The slope would be 1 point to the next. I'm going down 2, and I'm going right 2. So down 2 would be -2, and then right 2. Now that in lower terms is -1/1. And if you notice, really you're going down 1, right 1, down 1, right 1, down 1, right 1. In simplest form, that slope is -1. And that's all for that problem. I don't know if I have a video for this specific skill yet. I'll make one soon, hopefully. So we have this. Location of point B if it has a vertical translation of -12. Point B is at -2, 2. If we're going vertical, we're going to be changing the y value. And it's a translation of -12. So basically you're taking that y value and subtracting 12 from it. So your x value stays exactly the same. And 2 minus 12 gives you -10. So there you go. Now let's talk about reflecting over the x-axis. So this is your x-axis. Point B was 2 above the -2. It's now going to be 2 below. Point A was 4 below. Now it's 4 above. Point C was 2 above the 1. Now it's 2 below the 1. And there you go. We're connecting. I'm going to go ahead and name my new points. Point A is now going to be point A apostrophe. That means the image. Point B, oops, and I totally did that in the wrong spot. I'm just demonstrating a common mistake a kid might make. Yeah, that's what I'm doing. Point B was above, now it's here. Point A was below, now it's up here. C was above, now it's below here. There you go. Now it's right. Let me know if you think I made a mistake. All right. Okay. Quadrilaterals with the most accurate name. So this is going to be a rectangle. Now it's also considered a quadrilateral and a parallelogram, but we're going with the most accurate name right now. This would be a rhombus. This would be a square. This would be a trapezoid. This would be a quadrilateral. This would be a parallelogram. Now it asks about congruent diagonals. Diagonals are going to be things like this, and those two diagonals would be the same. The diagonals here in the square would be the same. The diagonals here in this trapezoid will be the same. These have diagonals, but this one's going to be a little longer than that one. Same thing here. This diagonal is going to be longer than this one. Not all trapezoids have congruent diagonals, but this is an isosceles trapezoid, so it's kind of special. All right, moving on. So first, we are looking at the table 2 equation. So am I multiplying each x value by 2? Well, 2 times 5 does not give me 3, so I'm going to get rid of that one. Am I adding 2 to the x? 5 plus 2 is 3? No. X minus 2. Am I subtracting 2 from each one? 5 minus 2? Check. 2 minus 2? 0 minus 2? Negative 3 minus 2. Yep, that's going to be the 1. I'm just going to double check. Half of x. Half of 5 is 3? No, it's not. So I'm getting rid of that. So now I'm going to take these points over here in this table and graph them down here. So the first one was 5, 3, 5, 3. 2, 0, x value of 2, y value of 0, 2, 0. 0, negative 2, there it is. And then negative 3, negative 5. Negative 3, negative 5. I connect them. The slope of this line. The slope of this line. Well, up 2, right 2. 2 over 2. Let's see. You can think of it from here to here. That's up 3, right 3. Either way, both of these break down to 1 over 1, which is just a big old 1. What kind of relationship is this? Is it additive or proportional? Let's check if it's proportional by looking at the table. If it's proportional, we should be able to do that ricochet thing we've talked about. 2 times 3 is 6. 6 divided by 5 is not 0. So it's not proportional, so it has to be additive. The other thing is, in our equation here, additive is always adding or subtracting, and we were subtracting here. Additive is when you're adding or subtracting. Proportional is when you're multiplying or dividing. And there's a lot of other cool things. Check this out. It's hitting the y-axis at -2. Our constant was -2. That's a huge thing that hopefully you'll catch on to over the next few weeks. All right, finally, this last one. The difference of 3 times a number and 2. I'm going to worry about that first. This is 22 is real easy. Difference of means you're subtracting. The two things you're subtracting are separated by the word and. 3 times a number and 2. Is 22. Is 22. Boom. So now, earlier this week we were doing just expressions where you just wrote down the expression, but now that we have an equation, we can solve it. So I'm going to add 2 to both sides, and then we're going to divide by 3, and we get n equaling 8. And if you wanted to double check, you could plug an 8 in here, and you could use Desmos for that if you wanted. That is it. I hope this helps. Let me know if you think I made any mistakes.